strong acids, strong bases, and what in the world is an ionization constant? So, it is defined as strong, whether an acid or a base, if it completely dissociates in aqueous solution, meaning the reaction only goes to the right. There is like no equilibrium. So, in a generic form, the concentration of H acid, that's the common generic form, is H and A for acid, equals, at the end of the reaction, the concentration of H plus or H3O plus, depending on how you want it. So this will be important for when we do ice tables. So you have to be able to identify, is this a strong acid? If it is a strong acid and the problem tells you that you start out with 1 molar, you know at equilibrium you have 1 molar of hydrogen ions. So 7 strong acids you need to know. This goes over pages. Yes, you do need to know these. All right, perchloric acid. Anybody know the formula?
Cl.
Yes, Cl.
5.
Close. Oh, ClO4. And then that's a -1, so it needs 1 H to balance it. Yes, remember the polyatomic ions. Sulfuric acid. H2SO4. Remember, 8 ions make ic acids. Nitric acid comes from nitrate, which is HNO3. Chloric acid. Yes, HClO3. See, you remember more of this than you thought.
I think it's just true.
Hydrochloric acid. HCl. Good. Turn the page. These are easy. Hydrobromic acid. HBr. Hydroiodic acid. Hawaii. HI. Now, the strong bases, there are also 7 of those. These strong bases, generally B for base with an OH. Mostly, these are a little bit harder. That's going to be your concentration of hydroxide ions. These are just ionic compounds, so these are easy to write their formulas. So lithium hydroxide, lithium is a +1, hydroxide is always -1. Sodium hydroxide, NaOH, potassium hydroxide, KOH, rubidium hydroxide, RBOH. Now let's write these others down. Calcium hydroxide, CaOH2, because these are all +2s, right? Yeah, it's okay if you're just agreeing with me because I said it. And then barium hydroxide. Now, a word about these strong bases that have a +2 charge. Unlike acids, when bases completely dissociate, they lose all their hydroxides at one time. So, acids only lose one proton at a time. Now, so if we were to write out calcium hydroxide, we're going to put it in water, and it's going to give you calcium plus 2 and 2 hydroxide molecules. So in your balanced equation, you're going to have twice as many hydroxide ions. You can see that from the formula. Is everybody with me right here?
Should you add in water? Where is that in the reaction?
It completely dissociates, so it doesn't matter. It's not going to react with water, it's just going to dissolve. So when calcium hydroxide dissociates, so when it breaks apart into calcium, and do you see there's 2 hydroxide ions? These all come off at the same time. So if you're working these problems, it's not meant to be a trick question. I just want to make sure I talk about it in case you encounter it on the homework or something. When you have these plus 2 cations, your concentration of your base is you're gonna end up with 2 times the concentration in hydroxide. So when you're running reactions, you would have to double the concentration of hydroxide that's produced. So if we're talking about concentrations, a 1 molar solution of calcium hydroxide is going to dissociate into a 2 molar solution of hydroxide, if you prefer that notation better. Does that make sense? Maybe I'm getting some head nods. Okay. Okay. All right. So 7 strong acids, 7 strong bases.